Hello everybody, thank you for joining me today. So if you're watching this video, that means you are in the first week of high school, first week of Earth Science. So first of all, welcome to Earth Science, welcome to high school. You have a lot to look forward to both in this course and in high school, and I hope you're excited to get started. So today what I'm going to be talking about is claim evidence reasoning. So what this is a framework for scientific writing, and it's the framework that we're going to be using all year when we're doing our scientific explanations. And there's a good reason for that, and we'll get to that soon. So when we talk about science, science is a way of knowing based on evidence. It's not just a set of beliefs that you can choose to believe or disbelieve. The whole nature of science is we're trying to figure out what is going on in the real world and how we can use real evidence to support what we're saying. So anytime we have something happen in the natural world, we sometimes call this a phenomena. So something that is in question that we want to explain. So in science, we go through some investigations, we gather our evidence, and once we get a good chunk of evidence and we think we have something here, we go through a logical reasoning sequence, which is how we arrive at our explanations. And all the while, we go through a critique process, right? So we critique our explanations, our evidence, and we critique what's going on in the natural world. So over time, you have many scientists reading the explanations of other scientists, trying to prove them wrong. And if over a long period of time we cannot do that, we arrive at a scientific theory. So this is a good little model to explain what happens here. So as I said previously, we are doing the claim evidence reasoning, but it doesn't necessarily go in that order. We don't really state our claim first. First, we gather our pieces of data, and then once we have our evidence, we can then state our claim. So what is it that you know based on this evidence? And then your reasoning is the synthesis between the two. So how does your evidence support what you are claiming? The reasoning is a very, very important piece. For me, as I was going through science, I was really good at picking out the evidence, saying my claim, saying the evidence over and over again, but I never really got to this reasoning, this logical connection. So that's kind of like your if, therefore kind of statement. So I will go through a model later in this video, and it might help you to do the same. So why should we use it? So the science standards in New York State, they now put more focus on the practices and the cross-cutting concepts in science. So practices, you're going to be expected to be a scientist, and you're going to be expected to perform all of these 8 practices. So with the claim evidence reasoning, we're going to touch on analyzing and interpreting data. So you're going to be presented with many different readings and data sets this year. You're going to construct explanations. That's what we're learning about today. And you're possibly going to be designing solutions. Also, you're going to be engaging in arguments using evidence. And then eventually you're going to get to obtaining, evaluating, and communicating information. So at the beginning of the year, I'm mostly going to be providing you the resources for your evidence. Obtaining and evaluating piece is not going to be there until probably November, December, and the communicating information, we're going to start right away. Our end goal by the end of this year is to get you here. So you're going to be asking the questions and defining the problems. Then you're going to go through these steps to communicate your information and your findings. So this is all exciting, and this is only going to sound like theory unless I model this for you. So I am going to go through a modeling piece. So every time we do science, we start with a question, right? So some sort of phenomena that's in question that we can figure out through the scientific process. So this first prompt that I have here is carbon dioxide a greenhouse gas? So this is going to be kind of simple. We're going to revisit this when we get to the greenhouse effect and climate change. But this is a nice, simple, easy question that I can use to model how we do this scientific writing. So my data is going to be this here. So this is an absorption spectrum based on a spectrophotometer. So this measures the amount of heat that is radiated by the different gases that are in our atmosphere. So on the y-axis we have percent absorption. So for each of these gases it goes from 0, 50 to 100, then resets for total. So they each have their own little scale here. And down here is the wavelength. So all of the electromagnetic radiation coming from the sun, it comes in different wavelengths. We only see within the visible spectrum, but we have near infrared and infrared. and then far infrared and microwave, as well as ultraviolet. So when we talk about the greenhouse effect, we're really only focusing on this infrared band. So that is your heat band. So in order to answer this question, we first must define all parts of the question. So first, what is a greenhouse gas? So like I said, we will get to this further towards the end of the year. But a greenhouse gas is a gas in the atmosphere that is capable of absorbing and radiating heat. So heat comes in the form of infrared radiation, infrared energy. So it's like heat coming from your stove. That's the wavelength that most snakes and some predatory animals see, and they can see the heat from their prey. And what is carbon dioxide? Well, carbon dioxide is a gas in the atmosphere that's composed of 1 carbon and 2 oxygen molecules. So it's a waste product of human respiration, so it's what we breathe out. And it's also a gas that's emitted from burning biomass. So if we burn a tree, it releases carbon. If we burn some fossil fuels, it releases carbon. So when I look at this data set, I have to really kind of look at what I'm looking for. So I'm trying to figure out if carbon dioxide, so this gas here, is this a greenhouse gas? Well, I know that greenhouse gases need to absorb and radiate heat, and we're talking about infrared, so I'm going to focus right within this infrared band. Okay, so within the infrared band, I can see that, so absorption is almost nearly 100 for this in both the far infrared, infrared, and near infrared. Okay. So if I look at oxygen and O3, they don't. Oh, but water molecules, they do as well. Okay, so what evidence can we gather here? Well, carbon dioxide absorbs nearly 100% of energy in the near infrared and infrared wavelengths, right? And we know infrared is heat energy, right? So greenhouse gases absorb and radiate that heat, and carbon dioxide can. So what am I going to claim? Well, I'm going to claim that carbon dioxide is a greenhouse gas. So reasoning, this is the hard part, right? So over here I have written my claim. So carbon dioxide is a greenhouse gas. My evidence is carbon dioxide absorbs nearly 100% of energy in the near infrared and infrared wavelengths. Infrared equals heat energy. Greenhouse gases absorb infrared radiation. So I have all my evidence here. I have my claim, but that's not enough. That doesn't prove that I know what I'm talking about here. So how do I write a reasoning? So let's go out here. Let's write in the box, right? So I'm going to do this real time just so I can think out loud so you can hear how I go through this process, right? So I'm going to first start off with what a greenhouse gas is, right? So a greenhouse gas is a gas in the atmosphere that has the ability to absorb and radiate heat as measured by spectrophotometry. Carbon dioxide absorbs nearly 100% of the infrared spectrum. Therefore, carbon dioxide must be a greenhouse gas. So this may seem redundant and kind of silly, to be quite frank with you, right? I have my evidence, I have my claim, I basically just stated it. But the important piece here is that I am saying what a greenhouse gas is and what it must do, right? Then we have carbon dioxide. Well, carbon dioxide absorbs infrared radiation, so therefore carbon dioxide must be a greenhouse gas. So this is a really simple model, but it's important that you know how to do this for when we get to bigger questions other than that is carbon dioxide a greenhouse gas, because you're going to be answering questions like, have humans influenced the greenhouse effect, and what does this mean for the future of the planet? So that is a big question, but if you do not know this skill, you're not going to be able to do this. So what I would like you to do for homework tonight is answer this prompt. So your prompt is going to be, is oxygen a greenhouse gas? So you're going to use the same data set that I use. You're going to use the same definition of a greenhouse gas. Again, it's a gas that is capable of absorbing and radiating heat, or infrared energy. And oxygen, it's a gas in the atmosphere, typically in the form of molecular oxygen, so O2, that's what we breathe, and that's what keeps us alive. And then also ozone, so that is 3 oxygen molecules instead. So in this graph, they have both molecular oxygen, and ozone. So go ahead, go through your claim evidence reasoning process, and I will see you all next time we have for class. Thank you very much. I hope this was helpful, and I look forward to a great year of earth science with you all.